Ever wondered what's happening inside your phone or remote? It's all about electricity, but you can't see it. That's where the multimeter comes in, your electronics detective. Think of it as a ruler, scale, and stopwatch for circuits. It measures voltage, the push, current, the flow, and resistance, the slowdown. With a multimeter, you can solve circuit mysteries like why a robot's light won't turn on, by testing batteries, wires, and bulbs. It turns problems into fun puzzles and gives you real answers, not guesses. In this guide, we'll break down the multimeter's parts and show you how to use it step by step. By the end, you'll peek into the secret life of circuits and understand the forces powering our world. Ready to become an electronics detective? Let's get started. Meet your multimeter. This indispensable tool is your gateway to understanding the world of electronics. It's a device that allows you to measure voltage, current, resistance, and a whole lot more. Think of it as your electrical detective, helping you diagnose problems and understand how circuits behave. Let's break down its main parts, so you can become familiar with each component and its function. Understanding these parts is crucial for using your multimeter effectively and safely. We'll go through each section step by step, highlighting what makes each one important. At the top is the display, your window to the numbers and units you'll measure. This is where all the readings will appear, whether you're checking the voltage of a battery or the resistance of a resistor. Make sure the display is clear and easy to read, as this will help prevent errors in your measurements. Some multimeters even have backlights for better visibility in dimly lit environments. The big knob in the middle is the selection dial. This is your primary control for choosing the type of measurement you want to perform. Turn it to choose what you want to measure. It's like selecting the right tool from your toolbox. Each setting on the dial corresponds to a different measurement function, so it's important to choose the correct one for your task. Voltage, V, which is the electrical potential difference between 2 points. Current, A, the flow of electrical charge through a circuit. Or resistance, omega, the opposition to the flow of current. Around the dial you'll see symbols and ranges. These markings indicate the specific settings and measurement ranges available for each function. Pick the right one for your job. Selecting the appropriate range is crucial for accurate measurements and to prevent damage to your multimeter. If you're unsure of the value you're measuring, start with the highest range and work your way down until you get a clear reading. At the bottom are the ports or jacks. These are where you'll plug in the test leads to connect the multimeter to the circuit you're measuring. The black port labeled COM is for the black test lead, your reference point. This is the common ground connection and is essential for completing the circuit for measurement. The red lead plugs into different ports depending on what you're measuring. Each port is designed for a specific type of measurement, such as voltage, current, or resistance. Voltage resistance, often sharing the same port, or high current, which usually has its own dedicated port. The test leads themselves. These are the wires that connect the multimeter to the circuit you're testing. One red, typically used for positive connections. One black, usually connected to the common or negative side of the circuit, are your multimeter's hands. They allow you to interact with the circuit and take measurements. Plug one end into the meter, making sure they are securely connected to the correct ports. And use the pointy probes to touch the circuit. These probes are designed to make contact with specific points in the circuit, allowing you to measure the electrical characteristics at those locations. The black lead is for the negative or common side. It provides a stable reference point for your measurements. The red is for positive, indicating the point with a higher electrical potential. These leads let you reach into circuits and feel the electricity. They are your direct connection to the flow of electrons, allowing you to quantify and understand the electrical behavior of the circuit. With these parts, you're ready to start measuring. Understanding each component and its function is the first step towards mastering the art of electrical measurement. Get familiar with them. They're your toolkit for every experiment. The more comfortable you are with your multimeter, the more effectively you'll be able to troubleshoot and analyze circuits. Let's move on to getting set up, so you can start putting your multimeter to work and exploring the fascinating world of electronics. Before you start, make sure your multimeter has a fresh battery. Check the display for a battery symbol. Plug the black test lead into the COM port. It always stays there. The red lead goes into the port marked for voltage, resistance, or milliamps. Unless you're measuring high current, then use the special high current port. Double check your leads are in the right spots to avoid damage. Now turn the selection dial from off to the function you want. That's it, your multimeter is powered up and ready. Always check your setup before measuring. Proper setup means safe, accurate results. With your leads in place and dial set, you're ready for your first measurement. Let's see what's happening in your circuit. On to voltage. Time to measure voltage. The electrical push in a circuit measured in volts. V. Set your dial to DC voltage, V with a straight line. For batteries, choose a range higher than what you expect. For a 1.5 V battery, the 20 V setting is perfect. Plug black lead into COM, red into VOMA, touch the red probe to the battery's positive end, black to the negative. This is called measuring in parallel. Check the display. A new AA battery should read just over 1.5 V. If you see a negative sign, swap the probes. That's it, you've measured voltage. Voltage tells you if your battery or power source is healthy. Use this skill to troubleshoot circuits and test components. Simple, right? Next, let's measure current. Now let's shift our focus and measure current. We're moving beyond voltage to explore another fundamental aspect of electrical circuits. Current represents the flow of electricity, specifically the rate at which electric charge passes a point in a circuit. This flow is measured in amps, often abbreviated as A. Think of it like measuring the amount of water flowing through a pipe. The more water, the higher the flow rate, and similarly, the more charge, the higher the amperage. Understanding amperage is crucial for designing efficient and safe circuits. Unlike voltage, which is measured across 2 points in a circuit, you measure current by making the multimeter an integral part of the circuit itself. This means the current you're measuring actually flows through the multimeter. This method is called measuring in series. The term series refers to how the components are connected in the circuit, one after the other, forming a single path for the current to flow. To insert the multimeter into the circuit, you first need to break the circuit open, which means disconnecting a wire to interrupt the current's path. Then, insert the multimeter to bridge the gap you've created. The multimeter effectively becomes a section of the wire, allowing the current to flow through it. Before you connect the multimeter, make sure to set the dial to DC amps. Look for the A symbol, often accompanied by a straight line, which indicates direct current measurement. It's always a good practice to start with a high range when measuring current. This protects the multimeter from potential overloads if the current is higher than expected. The black lead always stays in the COM, or common port. This is the reference point for all measurements. For measuring small currents, the red lead typically goes into the MA port, which stands for milliamps. This port is designed for measuring currents in the milliampere range. However, if you anticipate larger currents, you'll need to move the red lead to the 10A port, which is designed to handle currents up to 10 amps. Now, carefully touch the red probe to the wire coming directly from the positive terminal of the battery or power source, and touch the black probe to the component's leg or connection point. With the probes in place, the current now flows through the meter, completing the circuit, and almost instantly, the multimeter display shows the value of the current flowing through the circuit. In a simple circuit with a small LED, for example, you'll likely see a current reading of just a few milliamps. This indicates the amount of current the LED is drawing to light up. Remember, it's crucial to always use the correct port and range on your multimeter. Using the wrong settings can not only lead to inaccurate readings, but also potentially damage your meter. Measuring current is an invaluable skill that helps you understand how much electricity your circuit is actually consuming. This knowledge is essential for optimizing power usage and preventing overheating or other issues. Mastering current measurement is a key skill for both building new electronic projects and effectively troubleshooting existing circuits. It allows you to diagnose problems and ensure your circuits are functioning as intended. Now that we've covered current, are you ready to move on and explore resistance? Let's go. Resistance measures how much a component slows down electricity, in ohms, omega. Always remove the component from the circuit before measuring resistance. Set your dial to the omega symbol and pick a range just above what you expect. Touch one probe to each end of the component, it doesn't matter which way. The meter sends a tiny current and shows the resistance on the display. If you see OL or 1, select a higher range. Use this to check if resistors or wires are working properly. Resistance testing helps you find faulty parts and understand materials. Simple, safe, and super useful. Now let's try some experiments. Are you ready to dive into the exciting world of electronics? It's time for hands-on science. Get ready to put your knowledge to the test and explore the fundamentals of electricity with some simple, engaging experiments. Here are some easy experiments. Perfect for beginners and seasoned experimenters alike. These activities will help you understand the basics of circuits, voltage, current, and resistance. Let's start with batteries. Test different batteries. AA, AAA, 9V, and even some old ones you might have lying around. To measure their voltage, set your meter to 20V DC, which is the appropriate range for most common batteries. This setting allows you to accurately read the direct current voltage. Now measure new and old batteries and compare voltages. Notice how the voltage drops as a battery ages or is used. This simple test demonstrates the concept of battery life and energy depletion. Next, let's build a simple circuit. A fundamental step in understanding how electricity flows. Connect a battery and a small bulb or LED. Observe how the circuit works and the bulb lights up. This illustrates the basic principle of a closed circuit allowing current to flow. To measure the current flowing through the circuit, set your meter to measure milliamps, which is a unit of electrical current. To do this, break the circuit and insert the meter in series. This means the current must flow through the meter to complete the circuit. Observe the reading on the meter to see the current. This measurement tells you how much electrical charge is flowing through the circuit per unit of time. Now let's explore resistance, the opposition to the flow of electrical current. Try measuring resistors, which are components designed to provide a specific amount of resistance in a circuit. You can even measure the graphite in a pencil line. Graphite, being a form of carbon, offers some resistance to electrical flow. Draw a thick line, set your meter to a high resistance range as the resistance of graphite can vary. Then touch probes to each end. This will allow you to measure the resistance of the graphite line. Now move them closer and watch resistance drop. This demonstrates the relationship between length and resistance. Shorter length, lower resistance. Next, compare tap water and salt water resistance. This experiment explores the conductivity of different liquids. Observe the readings to see which conducts better. Salt water, with its dissolved ions, will conduct electricity much more effectively than tap water. Finally, try the continuity test, a quick way to check if a circuit is complete. Set your meter to continuity mode, which is specifically designed for this type of test. Look for a sound wave symbol. This indicates that the meter will emit a sound when continuity is detected. Touch the probes together, it should beep. This confirms that the continuity function is working correctly. Use continuity to check if wires or cables are broken. A common problem in electronics. If there's no beep, it means a break in the wire, preventing the flow of electricity. These experiments help you practice voltage, current, resistance, and continuity. They are the building blocks of understanding more complex circuits and electronic systems. Write down your results and see what you discover. Keeping a record of your experiments helps you analyze the data and draw meaningful conclusions. Each test builds your skills and confidence. The more you experiment, the more comfortable you'll become with using a multimeter and understanding electrical concepts. Experiment, observe, and have fun. Learning about electronics should be an enjoyable and rewarding experience. The more you try, the more you'll learn. Each experiment builds upon the previous one, gradually increasing your knowledge and understanding. Your multimeter is your ticket to discovery. It's a versatile tool that allows you to explore the fascinating world of electricity and electronics. Keep exploring. There's always something new to learn and discover in the world of electronics. Next, let's talk safety. It's crucial to understand and follow safety precautions when working with electricity. Safety is key. Always know what you're measuring, double-check your dial and range before connecting probes. Never measure resistance or continuity in a powered circuit. Turn off power and remove batteries first. Hold probes by the insulated handles. Never touch the metal tips during a measurement. Practice the one-hand rule. Keep one hand in your pocket to avoid current passing through your body. Stick to low-voltage battery circuits. As a beginner, never test wall outlets or high-voltage sources. Respect electricity, even at low voltages. Mistakes can damage your meter or your circuit. Good habits now keep you safe later. Always think before you touch. Follow these rules for safe, fun experiments. Now, let's see why this skill matters. Learning to use a multimeter is like gaining a superpower. You can see the invisible world of electricity. It's your first step from just using technology to understanding and creating it. Measuring voltage, current, and resistance connects science theory to real life. You'll build problem-solving skills, form a hypothesis, test it, and find answers. The multimeter turns frustration into discovery and builds your confidence. It's not just for engineers. Basic electrical knowledge is part of scientific literacy. With a multimeter, you can explore, experiment, and satisfy your curiosity. Wonder if a lemon can power a light? Test it. The world of electronics is open to you. Grab your multimeter and start exploring. Science is now in your hands. Go make discoveries.